particular integral corresponding to right hand side f of x. So the integral, and the notation that we use to denote the particular integral, it is yp, right? And y suffix p, that means p stands for particular integral. It is very first formula that we had seen in case of particular integral. If we have something like this operator auxiliary equation. So for example, if you are dealing with a differential equation of this kind, d minus a times y is equal to f of x, then we have to write the particular integral as yp is equal to 1 upon d minus a f of x. Okay, and the formula is that, so this root you have to take as a power of exponential term e to the power ax. Do not take negative. If there is a positive, then you have to take negative. Okay, and integral sign inside the integral side, take the negative of that root. Okay, so e to the power minus ax, and whatever the right hand side function you have, f of x dx, this is the formula for finding the particular integral. Okay, so note this formula. What is that? If we have 1 upon d minus a f of x, and if you want to operate this 1 upon d minus n of f of x, this is simply e to the power x inside integral e to the power negative x f of x dx. You have to solve this, and that will be the particular integral y suffix p. Okay, and what about if we have d plus a instead of d minus a? Second, if we have 1 upon d plus a f of x, then simply that formula will change. So instead of x, you'll get negative x outside and positive x inside f of x dx. Rest of the things remain as it is. Okay, only change in the sign. If you have plus a, then outside negative a. If you have negative a out, then outside will be positive a, right? Like that. Okay, so this will be yp. Second formula you can treat this as. Okay, and now what about if you have more than one root? So for example, if you have operator something like this, d minus a and d minus b. In that case, what will be the particular integral? How to find? So successfully you have to go, means first of all you can operate 1 upon d minus b, and thereafter you can operate d minus a, or you can do the partial fraction. You can separate these two operators, and then separately you can use the any one first or second formula depending on the root. Okay, so choices you can go successively or you can do the partial fraction. Okay, so after doing the partial fraction, you can separate out. You can write this way: 1 upon d minus a and plus b upon d minus b, and then you can operate on f of x separately. Okay, so choices your. So here I will write the formula. So 1 upon d minus a, and then in bracket 1 upon d minus b operating on f of x. And so this is simply 1 upon d minus a, and in bracket according to the formula number 1, we can write this way: e to the power bx integral sign e to the power minus bx f of x and dx. And after solving this term integral, okay, and after multiplying by e to the power bx, then again you have to operate this 1 upon d minus a to get the answer. Or as I told you earlier, you can do the partial fraction and thereafter you can operate it separately. Okay. Now let us solve some examples based on these three important formulas of finding particular integral. Okay, so very first example we already seen some examples. Now next example, solve d square minus 6 times d plus 9 y is equal to e to the power 3 times x divided by x. Now we have right hand side as e to the power 3x upon x, and we want to solve this differential equation. So whenever you have non-homogeneous differential equation, means right hand side you have some function of variable x, we need to find general solution. So general solution is nothing but the complementary function, that is solution of associated homogeneous differential equation, and addition with particular integral. Okay, so we need to find general solution. So consider associated homogeneous differential equation. Homogeneous differential equation. Okay, so it is d square minus 6 times d plus 9 times y is equal to 0. So this is associated homogeneous differential equation, and corresponding to that we have auxiliary equation. So therefore auxiliary equation is d square minus 6 times d plus 9 is equal to 0. And our aim is to find the roots of this equation, that is the possible values of d, right? So we can see this is just an expansion of what? This is just an expansion of d minus 3, isn't it? Right, d minus 3 whole square is equal to 0. If you expand this, you will get this term, right? And now we can equate separately. So therefore d minus 3 is equal to 0 or d minus 3 is equal to 0. So what we are getting? So we are getting d as 3, 3. So roots are real and repeated. So how to write complementary function? How to write this solution of this associated homogeneous differential equation? Y suffix CF. CF stands for complementary function. Okay. Now we can see roots are real and repeated. Therefore we have to follow case number 2. So that is C1 e to the power 3x plus C2 and adjustment of that x, right? C2x e to the power 3x. So this is the solution. You can write it this way: C1 plus C2x taking e to the power 3x common. One and the same. Okay. So this is complementary function. So one thing, half part we done. YCF. Now our aim is to find YP corresponding to right hand side. So to find YP till now we have general method. Okay. We don't have any other method. So let us use general method to find out particular integral. Okay. Next to find particular integral. So YP is given by whatever the operator you have, that operator you have to take to the denominator, 1 upon d square minus 6 times d plus 9. And right hand side you have to write it is e to the power 3x upon, I think, yes it is e to the power 3x upon x, right? Okay, fine. And after that do the factorization of this auxiliary equation. So this is 1 upon, as we had seen earlier, it is simply d minus 3 whole square, and this e to the power 3x upon x as it is. Okay, further I can write this way. This is 1 upon d minus 3 in terms of product, d minus 3 and e to the power 3x upon x. Okay, fine. After that we have to operate 1 upon d minus 3 successively to get the final answer. Okay, so what I will do, I'll just take 1 upon d minus 3 outside, and inside 1 upon d minus 3 operating it on e to the power 3x upon x using the formula. Okay, so fine, this is 1 upon d minus 3, and now inside, so let me write the formula here. Since 1 upon d minus a f of x, it is e to the power x inside e to the power negative x f of x, right? So this is the formula. So according to that, here we can see the value of a is nothing but the 3, right? Value of a is nothing but the 3. So therefore e to the power 3x outside, inside e to the power negative 3x, and whatever the function you have. So here we have the function e to the power 3x upon x, that you have to write into e to the power 3x upon x dx. And so you have to solve this integral. Okay, now we can see outside 1 upon d minus 3 still there is, okay, as it is 1 upon d minus 3, and now inside e to the power 3x. This e to the power 3x term is outside of the integral sign. Okay, do not take it inside. Okay, otherwise you will get the wrong answer. And integral, so this negate e to the power negative 3x and e to the power positive 3x, they will get cancelled to each other. So we left with only 1 upon x dx. And now can you tell me the what will be the integration of 1 upon x? Yes,
log x.
Very good. So this is e to the power 3x into this e to the power 3x as it is into log x, because integration of 1 upon x is log x. Okay, keep in mind. And so of course formula is required to solve the integrals. You should know all the formulas. Just go through it once again. Okay, if you don't remember. And now here we can see again there is a 1 upon d minus 3 operator outside of the square bracket. So we have to operate it. So again using the same formula that we used earlier. So this will be Now this time our function has changed. It is e to the power 3x times log x, new function we have. And on that function we have to operate this 1 upon d minus 3. So again, using the same formula, we can write e to the power 3x outside and inside e to the power negative 3x into e to the power negative 3. Sorry, this function you have to write. So this will be okay, fine. Into e to the power 3x log x dx and bracket complete. OK, and so this is e to the power 3x. Now this negative positive get cancelled into integration of log x dx. And now my question to you, what is the integration of log x? Do you know the formula for log x? Its integration. Yes. It is x log x minus x. OK, if you don't know the formula, then you can go with the Pipert rule. You can take u as a 1 and v as a log x, and then you can go with that formula. OK, I'll get this answer. So the formula, since I'll just mention here, since integration of log x is nothing but the x log x minus x. OK, if you don't know this, then I will suggest you go with the Pipert rule, where you have to identify u and v. So you can take u as a log x, v as a x. Let me solve this for you. OK, so here I can write integration of 1 into log x dx, and now I'll take u as a log x and v as a 1. So according to that Pipert rule, log x as it is, integration of 1 dx minus integration of derivative of log x, it is 1 by x, into this integral, it will be x dx. And so this is log x, integration of 1, it is x, and this x's get cancelled. Again, integration of 1 will be x. So we can see it is x log x minus x. So x log x minus x. So this is the proof. OK, if you don't need remember the formula. And so here we got particular integral yp. Yp is equal to e to the power 3x x log x minus x. And after that, we have to write general solution. Therefore, the general solution is given by is y is equal to ycf plus yp. But ycf we already got, it is c1 plus c2x and e to the power 3 times x. And what is the yp? Yp we have here, it is e to the power 3x in bracket x log x minus x. So this is the general solution of the given differential equation by general method. General method means what? We had used general formula for finding particular integral. That's why. OK, and now next example, where I'm going to discuss some little different example, and we could have difficult example so that you will understand the benefit of using general method. Next, solve d square plus 3 times d plus 2 y is equal to e to the power x minus sine e to the power x. Now this time we can see a very strange function we have at right hand side. It is e to the power x minus sine e to the power x. So process is simple. We have to consider associated homogeneous differential equation. We need to find the auxiliary equation. After that, we need to find its roots, and thereafter we have to write the solution accordingly. OK, now consider. I will directly consider auxiliary equation. Now you know the steps. OK, solution. Auxiliary equation is d square plus 3 times d plus 2 is equal to 0. Before that, let me just confirm. Whatever I'm writing, is it reflecting?
Yes, sir.
Yes, sir.
Fine. Thank you. Now d square plus 3d plus 2 is equal to 0. Now I want to find the roots. So you have choices. You can use calculator, you can use factorization method, you can use synthetic division, you can use any other method that like a quadratic formula or any other method that you know. So here what I will do, I'll just use the factorization because I can write this way. D square plus 2 times d plus d plus 2 is equal to 0 because I want the product 2 and addition must be 3. So I can write this way 2d plus d. Its product is of course 2 and addition 2 plus 1, that is 3. And now I can take d common. So therefore d plus 2 from the first term, and I can take one common from the last two terms. So that will be d plus 2 is equal to 0. Now I can take d plus 2 common. So d plus 2 in bracket I'll fit d plus 1 and is equal to 0. And then I can have the roots from these two factors. So that therefore I can write d is equal to minus 2 from the first factor and minus 1 from the second factor. So we can see roots are real and distinct. As they are negative, still it is okay. They are real and distinct, and therefore complementary function YCF. Do you know how to write this solution in this case? Can anyone tell how to write? If we have roots real and distinct.
C1 e raised to minus x plus C2 e raised to minus 2x.
Very good. C1 e to the power minus x plus C2 e to the power negative 2x. So this is the way of writing the complementary function. Okay, half part done. Now we are focusing on YP. Okay, next to find YP, that is particular integral. Next to find YP. So YP is given by 1 upon whatever the operator you have, that auxiliary equation d square plus 3 times d plus 2 in bracket right hand side function you have to write. So right hand side function is this e to the power x minus sine e to the power x. Fine. Now do the factorization of this. So we already got the factors. You can see here d plus 2, d plus 1. So we can write those factors directly here. All right. So this is 1 upon d plus 2, and here we have d plus 1, and in bracket e to the power x minus sine e to the power x. Okay, all right. Now we can apply a d plus 1 first, and thereafter we can apply d plus 2. So let us apply it. Apply the formula first. General method. Okay, so d plus 2 I'll just keep as it is, and here I'm going to apply d plus 1. Now see, I have already told you, if you want to do partial fraction, you can. It is not necessary to apply it successively. You can do the partial fraction, you can separate this two, and then separately you can apply. Choice is yours. Okay, so e to the power x minus sine e to the power x. So here let us apply that formula. So this is 1 upon d plus 2 is as it is, and now according to the formula number 2. So let me recall that formula here. Since 1 upon d plus a f of x, this time we have plus a here, right? Like a plus 1. So plus a. In that case, exactly opposite, negative you have to take outside. So e to the power negative x, and inside positive e to the power ax f of x dx. Okay. So according to this formula, we can write here e to the power negative x outside, and inside we will have e to the power positive x, and whole function as it is. Okay, I'll write in parentheses. Okay, e to the power x minus sine e to the power x. Okay, so this is the way of finding the particular integral using this formula. And now our aim is to solve this integral. Okay, we have to solve this integral. And after that, one more time we have to apply 1 upon d plus 2. So to solve this integral, do you have any idea how to solve this? Means any suggestion, or do you know any method or any substitution that we can use here? So what substitution I have to do here?
E raised to x is equal to t. Or
very good, very good. So just focus on this integral. Okay, this function. Do not consider this function. This is totally outside of the integral side. So just keep this as it is. Okay, so just focus on this term. So put e to the power x is equal to t. So therefore e to the power x into dx, that will be dt, right? So we can replace this e to the power x into dx by dt, and the term which is inside this bracket, we can put e to the power x as a t. So this integral will look like, so I'll just solve it. So this 1 upon d plus 2 as it is, and square bracket e to the power negative x as it is, and this integral will look like e to the power t, because e to the power x is t, minus sine t and this e to the power x into dx, we have its value dt. Bracket complete. Okay, now we have to solve only this integral, and now it is quite simple. So this will be 1 upon t plus 2 in bracket e to the power negative x, and integration of e to the power t, it is e to the power t. Integration of sine t. What is the integration of sine t? What is the integration of sine t?
Minus cos.
Minus
Yes,
cos.
it is minus cos t. See, derivative of sine t is cos t, but integration of sine t is minus cos t. Okay, so negative negative here already we have negative negative become positive cos t. Fine. After that, use back substitution. What we have the value of t, it is e to the power x. So this will be 1 upon d plus 2 e to the power negative x, and inside this will be e to the power x, because t is nothing but the e to the power x, and this will be cos e to the power x. And now let us apply this 1 upon d plus 2 using the same formula. Okay, so this will be e to the power negative 2x outside and inside e to the power positive 2x, and this whole function we have to consider this whole function. Okay, so e to the power negative x in bracket e to the power x plus cos e to the power x dx. And now we can simplify it further. Therefore, it is e to the power negative 2x integral e to the power 2x and into e to the power negative x. One e to the power negative x will get cancelled, so we left with only e to the power x, 2x minus x, that will be x, and inside e to the power x plus cos e to the power x dx. And to solve this integral, again we can so put, so therefore e to the power x into dx, that will be dt. So using this substitution, this integral look like outside term as it is e to the power negative x, inside this e to the power x into dx, that will be dt, and this will be e to the power t and plus cos t, because e to the power x it is t, right? And this e to the power x into dx, that is nothing but the dt. Now solve this. So this will be e to the power negative 2x outside, and inside integration of e to the power t with respect to t, it is e to the power t, and integration of cos t, it is sine t. Okay. And now use the back substitution. T is equal to e to the power x, so that will be e to the power negative 2x inside e to the power x plus sine e to the power x, using the back substitution. And this is the required answer, particular integral yp. And earlier we got complementary. Yes. Yes.
सर टी लिहायचा राहिलाय का तुमचा?
काय लिहायचं राहिलाय?
सर जे इक्वेशन आलेलं ते एकदा चेक करा. पुट करायच्या आधीचं इक्वेशन. हा सर ते एक्स आहे ना त्याचं टी लिहायचं राहिलंय.
एक्स कुठे?
सर पुट केलं ना आपण e to the power s equal to t. सो इंटिग्रेशन टी सर. जेवढचं इक्वेशन आहे ना सर करायच्या आधीचं.
हा इथे म्हणतोयस का? हा इथे काय करायचं?
तो सर खाली पुट केल्यावर इक्वेशन मध्ये लिहायचं राहिलंय.
नाही हे बघ, हा e to the power 2x into e to the power negative x हे कॅन्सल होणार आहे. ही स्टेप तर कळली तुला, बरोबर आहे? मी हायलाइट करतोय. त्याच्यानंतर मी सबस्टिट्यूशन यूज करतोय. काय सबस्टिट्यूशन केलंय मी? e to the power x is equal to t, बरोबर आहे? मग e to the power x is equal to t, therefore e to the power x into dx, that will be dt. म्हणजे हा टर्म आणि हा टर्म डायरेक्टली आपण रिप्लेस करणार आहे dt बरोबर, राईट? अरे राहिला आता प्रश्न हा ब्रॅकेटचा. तर ह्या ब्रॅकेटमध्ये e to the power x आहे, म्हणजे हा e to the power x मी लिहिला t, म्हणजे ही टर्म आली, आणि करस्पॉन्डिंग टू दिस cos t.
समजलं सर.
हा, आलं लक्ष? So this is yp, and now finally we have, therefore y is equal to ycf plus yp Now YCF we already got. It is C1 e to the power negative x plus C2 e to the power negative 2x. And here we have YP e to the power negative 2x and e to the power x plus sine e to the power x. This is the general solution. Okay. All right. So far we discussed about general method and its use. Now it's time to have some shortcut formulas. So let me start with the simple example, and there I will discuss in detail what are the shortcut methods. So before that, let me give you one example. Solve d square minus 1 times y is equal to 1 plus e to the power negative x bracket square. So can we have some shortcut formula instead of using general method? Of course, you can use general method to solve this example, but sometimes what happen, you may stuck in integral, right? Sometimes integral to solve integral may not be easy. OK, so it will be better if we have shortcut formulas. So the very first shortcut formula we have, it is about exponential term. OK, so first shortcut formula. Shortcut formulas for finding particular integrals. Okay. So the very first rule we have, you can treat this as a rule or you can say property number 1, rule number 1, whatever you want. So rule number 1, there is restriction on f of x if ever f of x side of the given function, given differential equation. If f of x is e to the power a times x, where a is any constant, okay, where a is any constant. Okay. Now in this case, what is the formula, shortcut formula for finding particular integral? So yp, but I'm talking about particular integral, not about complementary function. Okay, so yp is given by directly. See, let's say your auxiliary equation is this phi of d, and given differential equation, let's say phi of d times y is equal to f of x. This is your given differential equation. And now we can see auxiliary equation is nothing but the phi of d. In terms of talking about phi of d, it will be phi of d, 1 upon phi of d, our inverse differential operator method, and operating it on right hand side, that is e to the power ax. Up to this everyone know, but after that what? We don't want to use general method. So can we have any other formula? Yes, you have. This is directly you have to write 1 upon, just replace the value of d by this constant a. So this will be phi of a e to the power ax. So directly you will get some constant number at the denominator. OK, instead of that operator. For example, if you have 1 upon d plus 3 e to the power, let's say 2 times x, you came across this term and you don't want to use a general method like that, e to the power negative 3x outside and integral e to the power positive 3x into e to the power 2x dx. OK, so instead of that, what you can do, you can directly substitute the value of this d as this constant 2. So this will be 1 upon 2 plus 3 e to the power 2x. That is simply 1 upon 5 e to the power 2x. This is the particular integral. OK, so very simple formula we have here. Only you have to replace d by a. OK, what is a? You can see a is the power of that exponential term, a times x. OK, that constant you have to take in place of d. But sometimes you may get 0 at the denominator. OK, provided that phi of a is not equal to 0. If phi of a is equal to 0, then there is a problem, right? So what to do in that case? Now further, if you get phi of a 0, if your phi of a is equal to 0, then little modification we have in the formula, yp is given by x multiplied by x. This is totally outside, and then 1 upon phi dash of a e to the power ax. What is this phi dash? Phi dash means you have to take the derivative of that operator with respect to d. For example, if you have d 1 upon d square minus 1 and you have this function e to the power x. Now what is the coefficient of this x at power? It is 1. Now if you substitute using this formula, if you substitute 1 here, what you will get 1 upon 1 square minus 1 e to the power x. So that will be 1 upon 0. Okay, so how to solve this thing? To solve this thing, we have this second formula, multiply outside by x. So that will be answer of this will be x, and take the derivative of this operator with respect to d. I'm telling you with respect to d, not with respect to x. So with respect to d, it will be 2 times d, and this is just a constant, that will be 0. Okay, with respect to d, and this term e to the power x as it is. Now we can see there is no problem by replacing the value of d this time. Now we can put the value of d as this coefficient of x. We can see 1. Now this will be x into 1 upon 2 into 1 e to the power x. That will be x by 2 e to the power x. This is the particular integral. Okay, so I will explain in detail all these things. So I'm just telling you what you have to do in case you are getting phi of a is equal to 0, and provided that in this case phi dash of a has to be non-zero. Now further, if your first derivative is also 0 at that point, what to do? You have to go further. Now if your phi dash of a still you are getting 0, then again little modification, yp is equal to multiply one more time by x. Already we have x. Now this time it will be x square, and take the double derivative. So this will be phi double dash of a e to the power x, and provided that phi dash of a is not equal to, phi double dash of a is not equal to 0. Now what about if you get phi double dash of a 0? Then you have to go further. Okay, so if phi double dash of a still you are getting 0, then one more time multiply by x. Yp is equal to, this time it will be x cube 1 upon phi triple dash of a e to the power x, and provided that phi triple dash of a is not equal to 0, and still you are getting phi triple dash of a 0, go further. Okay, and so on I can say, right? So somewhere you will get non-zero, somewhere definitely you will get non-zero term. Okay, so let me explain particular example or this shortcut formula. Okay.
Okay.
Yes.
Sir, can you explain again that phi dash a equals to 0?
I will explain it with the help of example. You will not understand this directly. Okay.
Okay, sir.
Yeah. So let me take just for understanding. Let me take one example. We will understand all these examples one by one. Okay. Sorry, all these shortcut formulas. Okay. So example number 1. Solve. Okay. So let me take any random. So d square plus 1 y is equal to e to the power, let's say, minus 5x plus let's say 1. Okay, and we want to solve this differential equation. The process is simple. So let me drop this one first of all. You may face problem here, and let me explain with this. Okay, so associated homogeneous differential equation, you know, auxiliary equation, you know, therefore auxiliary equation is d square plus 1 is equal to 0. Okay, fine. Now let us find out the roots. We can see roots will be imaginary, so therefore d is equal to plus minus I, square root of -1, right? And we have complex roots. Now in case of complex roots, we have to write the solution as y is equal to e to the power alpha x in bracket a cos x cos beta x plus b sin beta x. But here we can see the values of alpha and beta. Value of alpha, it is 0 because you can see roots can be written as this way, I minus I, and real part is 0, imaginary part is coefficient of I, that is 1. So therefore in this case YCF is, it is e to the power negative e to the power 0 times x, and here we don't have beta. Beta means here we have 1, so that will be 1 times x, and here also we have beta as 1, so therefore that will be. So this is the complementary function. So this is simply a cos x plus b sin x. Now once we get complementary function, now our aim is to find out x plus b sin x. Okay, y shape is what? A cos x plus b sin x. And now finding particular integral using the shortcut formula. Next to find particular integral. So yp is equal to, process is same. We have to consider that differential operator 1 upon d square plus 1 operated on right hand side function e to the power negative 5x. And this time we are not going to use the general method. We are going to use shortcut formula number 1. What I said to you, I just said you key you have to replace the value of d by this coefficient of x of exponential term, right? So here we can see the value of d. What is that? Minus 5. Now we can put d as minus 5. So this will be 1 upon minus 5 whole square plus 1 e to the power negative 5x. And now we can see 1 upon negative 5 square, that will be 25. 25 plus 1, that will be 26. So 1 upon 26 e to the power negative 5x is the particular integral. So do you understand this formula? What I did? Yes.
Yes, sir.
Only you have to replace d by that term. Now let me take second. First of all, let me write general solution as usual. So therefore general solution is y is equal to ycf plus yp. So that is a cos x plus b sin x plus 1 upon 26 e to the power negative 5x. Very simple we have. Okay, shortcut formula. And now let me take one example where we will have 0 at the denominator while using the particular formula, shortcut formula. Okay, second example, d square minus 1. Let me take any other instead of 1. So let me take 3, or let's say 9. Y is equal to 0 e to the power 3x plus 1. I will explain both the cases. OK, here this time we have e to the power 3x and here we have constant 1. You can take any other constant, not necessarily 1. You can take 5 or any other. OK, now in this case, complementary function we have to find. So therefore auxiliary equation d square minus 9 is equal to 0. So therefore d is equal to square root of 9. That will be plus minus 3, right? And so therefore roots are real and distinct. So complementary function ycf according to the case number 1, c1 e to the power 3x plus c2 e to the power negative 3x. OK, we got half part. Now next to find particular integral. OK, next to find particular integral. So therefore we can use shortcut formula number 1. Yp is equal to 1 upon that operator d square minus 9 operating it on right hand side function, that is e to the power 3x plus 5. Now here let me explain one thing. You can separate this operator. OK, so I can write this way. 1 upon d square, you can distribute it actually. 1 upon d square minus 9 on first term plus 1 upon d square minus 9 second term 5. OK, and now for first term we can see if we replace d by this 3, what will happen? If you replace d by 3, that there will be problem. What is the problem? You will get 1 upon 3 square minus 9 e to the power 3x. But what is 3 square? 9. 9 minus 9, 0. There is a problem. So in this case, what we have to do? as I told you earlier, we have to multiply by x if we are getting 0 at denominator. Okay, then multiply by x and take the derivative of the denominator with respect to d. Okay, whatever the operator you have at denominator, d square minus 9 we have. Now what is the derivative of this d square minus 9 with respect to d? It is 2 times d minus 0 e to the power 3x. And this for second term. So by the way, do you understand what I did here? 2 times d minus 0. What is that? So let me explain it. If we have, instead of d square minus 9, if we have x squared minus 9. Now what can you say about its derivative with respect to x? With respect to x, we can say its derivative is nothing but the 2x. Now instead of x, if we have this d square minus 9, and I'm asking you what is the derivative of d square minus 9 with respect to d. I'm not saying with respect to x, I'm saying with respect to d. That will be same 2d minus 0, right? Like that. And here what I did, if you are getting 0 at denominator, you have to take the derivative, right? And this term as it is. Plus, for second term, what we have, we just have 5 as a constant. We don't have exponential term. So can we have exponential term here with along with that constant? Constant we can take outside. So taking outside that constant 1 upon. Here what we can write, e to the power
0.
Right, e to the power 0x, that is simply 1, and 5 just a constant. We can take it outside of that operator. Fine. Now we don't have any problem. Now we can replace the values of d here and here as well, right? Now just replace x is outside and 1 upon 2 into this time we can put the value of d as 3. So 3 minus 0. So no need to write that 0. And this term as it is, e to the power 3x. And plus 5, and here we can replace the value of d by 0. So that will be 0 square minus 9 e to the power 0x. And now solve this. So therefore it is x upon 6 e to the power 3x, and here we have divided by minus 9. So that will be minus 5 by 9, and e to the power 0x simply 1. No need to write this. So that is simply 1. OK, so this is particular integral where we used second formula of shortcut method, means second formula means second version of that formula if we are getting 0 at the denominator. So I hope you understand two cases. Yes. Any doubt?
Yes,
OK, so therefore finally of course you have to write general solution, that is YCF plus YP. So YCF is plus minus 3 now. So C1 e to the power 3x plus C2 e to the power negative 3x, and here we have x by 6 e to the power 3x minus 5 by 9. OK, fine. All right. Now let me take one example where you have to do little adjustment, okay, while solving that example. Second, third, solve. Let's say, okay, d minus 5 whole square y is equal to e to the power 4x plus 3 plus all right, 2 to the power x. OK, I want to solve this example. Now we can see we don't have a problem up to first two term. We can use the formula. But what about this third term, 2 to the power x, that we have to see. The process is simple. Let us find out complementary function. Therefore, auxiliary equation is d minus 5 whole square is equal to 0. So this implies d is equal to repeated roots. We have 5 comma 5 because whole bracket square is equal to 0. So d minus 5 is equal to 0 or d minus 5 is equal to 0. You'll get repeated roots. Now, if you are getting repeated roots, can you tell me a complementary function? What will be that?
C1 plus C2x whole into bracket and multiplied by e raised to 5x.
Very good. OK. And next, our aim is to find yp using the shortcut formula. OK, next, yp is given by 1 upon that operator d minus 5 whole square. and operating it on right hand side, e to the power 4x plus 3 plus 2 to the power x. Fine. And separate it, means you can distribute. Okay, d minus 5 whole square on first term plus d minus 5 whole square second term and plus 1 upon d minus 5 whole square on third term. Okay, so we don't have a problem with first two terms. We can write directly. We can replace the value of d by respective values of that. Okay, you can see here we can replace d by 4. So that will be 4 minus 5 whole square e to the power 4x. Now here 3 can be taken outside and e to the power 0x. Okay, so 3 and then 1 upon d minus 5 whole square and then e to the power 0x. So we can replace d by 0 in short. So that will be 3 upon 0 minus 5 whole square. And for last term, I'll just keep it as it is. Later on I will explain what to do with last term. D minus 5 whole square and this 2 to the power x as it is. Okay, fine. First of all, solve these first two terms. Okay, so this will be minus 1 square, that will be 1, and this e to the power 4x. 3 upon minus 5 square, that will be 25. So this is 25. And now we want to solve this. To solve this, we have to do adjustment. Adjustment means a conversion of this 2 to the power x function in terms of exponential function. Can we convert this 2 to the power x in terms of exponential function? Can we? Yes. Yes, yes, yes or no. Can I write this way? 2 to the power x is equal to e to the power x times log 2. Can I write this way? Yes. Do you know this thing?
Yes.
Yes.
Right. So e to the power x log 2, using the property of logarithm, it will be e to the power log 2 to the power x, and e and log get cancelled to each other. So that will be simply 2 to the power x. Yes, we can. So 2 to the power x can be written as e to the power x log 2. Okay, so in general, if we have a to the power x term, then we can write it as e to the power x times log a. So in particular, we have value of a as 2. In general, you can take any value here, a, right? So a to the power x can be converted as e to the power x log a. So what is our coefficient this time? We have log a. In this case, we have log 2. So here I can write this term 2 to the power x as e to the power x log 2. And we are interested in coefficient of x, because we want to replace d by that coefficient. So here we can see the coefficient is log 2. So therefore this will be e to the power 4x plus 3 by 25. And now I can replace the value of only d by log 2. So 1 upon log 2 minus 5 whole square. And this term e to the power x log 2 as it is. Okay. And now once we substitute the value of d, now we can rewrite that e to the power x log 2 as 2 to the power x. So this will be e to the power 4x plus 3 by, here we have addition sign, 3 by 25 and plus 1 upon log 2 minus 5 whole square into, again rewriting that 2 to the power x. So this is the particular integral where we learned, if we have, instead of exponential term, if you have any other 2 to the power x or 3 to the power x, a to the power x term, we can convert it, we can write it in terms of exponential term, and then thereafter we can replace the value of d by that coefficient. Okay, so finally we have to write that for y is equal to ycf plus yp, that is c1 plus c2x e to the power 5x, and this particular integral you have to write as it is, e to the power 4x plus 3 by 25 plus 1 upon log 2 minus 5 whole square 2 to the power x. Now let me ask you quickly one example. It's very simple. I just want to check whether you understand or not.